So in this video, I want to introduce you to this idea of completing the square. And this is a process that we use with quadratics. And I'm going to work through this quadratic as an example. So x squared plus 8x plus 3. So the idea is, and where the name of completing the square comes from, is that we would like to be able to write this as a perfect square. Now, I'll show you what that means in a moment. The first thing is thinking and considering these pieces as, let's say, rectangles. Okay? So, first of all, the x squared. You could think of that as a square of side length x. And what we're going to do is we're essentially going to build a square where, because we want 8x, it would make sense to have a block here that is of length 4 and another block here that is of length 4, because then you'll have 4x and 4x that will make up the 8x, and you've obviously got the x times x, which is the x squared. So in total area that we have currently, we've got the x squared plus 8x. Okay? So the idea is, well, this missing section here, because if you imagine this as a multiplication grid, this would be 4 times 4, so that would be 16. So I would need to add on 16 there to complete that square. Okay? So I want to be able to write this in a format where I've got x plus 4 squared. So x plus 4 times x plus 4. And this is what I mean by a perfect square. Okay? So a perfect square, nice x plus 4 squared. This is what I've currently got. What do I need to add on to make this? Well, I've already got that plus 3, remember? And I need to make it up to 16. And so I would need to add on 13. 3 plus 13 makes the 16. And now this is actually the same as this. Okay? Now, if I subtract that 13 from both sides, I can then write the x squared plus 8x plus 3 as x plus 4 squared take away 13. And so what I've done is I've rewritten the quadratic in what we refer to as completed square form. Okay? So this is what the result is, and that's where I want to get to. Now you might be wondering, well, why? Why do I want to do that? Well, there is something particularly useful about this format. It actually tells you the location of the turning point of the parabola. So we understand that these are parabolas, they have this shape, and this actually tells us the coordinates of this point here, the turning point. So you can actually read it straight off from here now. The coordinates of this point will be -4, so the number inside the bracket changes sign, and the one outside stays the same. So the coordinates of the vertex there would be -4, -13 for that parabola. Now the actual process of completing the square, I don't want to have to do this every time. Okay? So let's see if we can figure out what the process would be. Actually, I won't rub anything up. We'll leave it there. So thinking about how would I get from here to this? Well, I would start off by writing x plus, and the 4 came from splitting the 8x into 2 pieces. So I need to halve the number that's in front of the x, the coefficient of x. So I halve that number squared. Okay? So I do that as my first step. Then what I do is I think, well, I've got the x plus 4 squared, but what that has done is it's created this square here, and I've got this extra 16. Imagine that you don't know about that extra 3 yet, okay? And just imagine you've got this, x squared plus 8x. So we've got x squared plus those two pieces. But when I write this down, that also gives me the 16. So I don't want the 16 to be there. So I subtract 16 away. We subtract this number squared away. So now this is identical to that. Okay? Then I add the 3. The 3 was still there. And what we get left with is x plus 4 squared. Take away 16 plus 3, or minus 16 plus 3, it's minus 13. And that is where the minus 13 comes from. Okay? So, let's see another example. Let's see if we can go through those steps with another example. So let's say instead I had x squared plus 6x plus 1. Well, the process that I did first was I opened up a bracket and I want to have x and then plus half of this coefficient. So half of the 6 is 3, and square that. And then we want to subtract this number squared. So take away 3 squared, so take away 9. And then I've got the plus 1 on the end. So we have x plus 3 all squared minus 9 plus 1 is minus 8. Okay? And then, if I need to, I will be able to write down the turning point of the parabola. Let's do another example. Let's say I've got x squared, sorry, don't need the bracket yet. X squared take away 4x, take away 9. So, how would that work? Well, I would have x, and then I need to halve the number that was in front of the x. So here it was positive 6, here it's negative 4. So I halve negative 4, so that's minus 2, squared. Then I take away this number squared. So just like here, I took away 3 squared. Here you take away 2 squared. So you can kind of ignore that minus sign there, and you just subtract 2 squared. You will always be subtracting at this stage. Okay, regardless of what's in here, you always subtract. So we take away the 4, and we've still got minus 9 on the end. So we have x take away 2 squared, take away 13. And now it's in completed square form. So this is the process that we go through, okay? And in the next few videos, we will be practicing this.